Good afternoon. If you don't know me, I'm Jenny Sabin, Professor of Architecture and also the inaugural chair for our new multi-college Department of Design Tech, which is a unique collaboration cutting across departments and colleges administered by AAP in collaboration with Cornell Tech, Engineering, Bowers, Computing and Information Science, and Cornell Human Ecology. And we welcomed our inaugural class of students, many of whom are here in the audience just this past fall after about 5 years of pilot work leading to this really exciting launch. So I'm super excited to welcome Marcelo Coelho, who is also one of our inaugural Design Tech Innovation Fellows as a visiting lecturer with us this year. Marcelo embodies many of the sort of concepts and innovative technologies and pedagogical models that we explore in design tech, and especially centrally around one of our hubs, which is design plus interactions. So Marcelo is the director of the MIT Design Intelligence Lab, and he also teaches at MIT. He was the former design director at Formlabs. Many of you are probably familiar with Formlabs, and he's currently a visiting artist there, I just learned. He develops new objects, tools, and interactive experiences, and his work importantly seeks to reveal and bridge the gaps between matter and computation. So matter, design, computation, the precursor program to design technology, clearly shares some synergies with Marcelo's work. He has exhibited internationally, including places such as the Rio 2016 Paralympic ceremonies, which I just learned was a huge event, but was short-lived. He's also exhibited work in Times Square, the Corcoran Gallery of Art, the Tel Aviv Museum of Art, and Arts Electronica in Linz, Austria. His work can also be found in museums, private collections, and billions of products sold all over the world. Recognition for his work includes 2 Prix-Arts Electronica awards, and if you are not familiar with those awards, that's a pretty big deal to win one of those awards. He's also been awarded the Design Miami Designer of the Future Award, the Red Dot Design Award, and Fast Company's Innovation for Design Award. Marcelo holds a doctorate from the MIT Media Lab, where he's also a lecturer. He teaches graduate and undergraduate studios in artificial intelligence, physical design, and human-computer interaction. And I'm thrilled to also announce that Marcelo is co-teaching with Daniel Leithinger our core required course in design for physical interaction this fall as well as into the spring. So please join me in welcoming Marcelo.
Thank you. Can you guys hear me well? Great, awesome. Thanks for having me. It's been a really amazing time. Ithaca is beautiful. I did not know it before coming here, and it's been a really kind of exciting and sort of special time to get a chance to come here and spend time with everybody. I think what you mentioned, I think, Jenny, is really important. I think that I feel very at home here, and I think this has been really special, so thank you. Cool, I have a lot of work to show, which probably means that I'll start and then maybe race halfway, and then kind of conclude at some point. But part of what I want to show a lot of work is that I'm hoping to get to connect with folks here. I'm sure there's something in the presentation that maybe relates to some of the things that you're interested in. And if there are, please come talk to me. I'd love to connect with folks and get to meet more people while I'm here. Cool, so let me start. So I'm originally from Brazil. I started my undergraduate studies in Brazil, studying history and then filmmaking, and then moved to Canada, where I ended up getting a degree in design and computer science in Montreal. And then eventually did my master's and PhD at MIT, at the MIT Media Lab. And today I do many things. So I have an independent practice. I work on products. I worked at Formlabs for many years. and also teach at MIT in our design major and minor programs, which in many ways is sort of an undergraduate version of the design tech program. So it's probably no news to any of you that in the last few years, computing has become generative, right? Where we think of computers as kind of a different beast at this point. Roughly you can ask for what you want and you get it. So this is an example of a prompt for generating code for a camera. It captures an image and saves it to a hard drive. And a similar thing is happening with design today. And prompting has become kind of a new computational design skill. Maybe like a quick show of hands, who has used some kind of large language model for doing your homework? Nobody. All the hands go up, great. But what's interesting, I think that with domain-specific knowledge, you can get a much better generation, right? We talk a lot about AI being very accessible, making things accessible. But it turns out that if you're a designer, you can get better design generation using this models than somebody else. So maybe he's not trained as a designer, which I think is really interesting. So in this case, I have specified a design style, CMF, and kind of a rendering quality to get the exact image that I was looking for. But an image of a camera is not a camera, right? And as designers or engineers, we need to account for things like material properties or fabrication and manufacturing constraints, the environmental impact of the things that we make, the human needs that we serve, and the overall sort of context and context of use. And I think in the next 10 years, AI in particular become increasingly physical, not only through robots, which is what we hear a lot on the news, but also embedded into materials, objects, in our spaces. And this new class of physical computing, while embodying a lot of the kind of previous generation of physical computing, I think it's also going to be different in many, many ways. Natural language will be a big part of it, so these new kinds of computers will be able to talk to us using natural sort of human language, and perhaps even talk to each other using human language, which I think is very interesting because we can listen in. Their interfaces and behaviors will be generative, they'll be created on demand. They'll be predictive. They'll know what to do before you even know you need them, and they'll sort of kind of perhaps create themselves. And they'll be able to work together as agents as well, and create new kinds of capabilities by doing this. So in my work, I have tackled this challenge of making computing physical by typically working across 3 levels: objects, interactions, and networks. These are in no way sort of exclusive. In my presentation, I kind of break things down into these categories, but every time I do this, I realize how that doesn't make any sense. Every project has a little bit of all those things, and they kind of intermix in all these different and interesting ways. So I think you see some of that. And this has ranged from inventing kind of new kinds of computational materials and objects, to creating new ways of interacting with them, and to scaling those into sort of large scale, like physical networks of kind of humans and computers working together, going literally from the scale of a grain of sand to the size of a stadium. So let me show you some examples of some of the stuff I'm talking about. So Sandcastles is a series of photographs that I've done in collaboration with this Brazilian artist called Vic Muniz that explores these limits of visual perception and physical representation by drawing castles onto grains of sand. It's like tiny little grains of sand. Let's see if we can play the video. There you go. So we started with a camera lucida and doing camera lucida drawings. Camera lucida is this kind of old instrument that you can use to draw what's right in front of you by sort of visualizing it on like down here on whatever sketchbook you might have. It's kind of a pre-photography technique, how you create kind of very sort of representational image by using some of the sort of pre-photography, but not quite photography yet. So after creating this image of castles, what we did is we used the focus ion beam, which is the machine that you see in this video, to etch this image onto a grain of sand. And then we used a scanning electron microscope to image them. So it's kind of, in many ways, it's photography without photons, because you used ions and electrons to create an image. So we started pre-photography, and then we ended in the sort of post-photography world where cameras are perhaps not even needed, which in many ways resembles what's happening today, where you can create images without cameras, which I think is very, very interesting. And this kind of equipment is typically used for fixing integrated circuits and sort of for working through electronics, but in this case, we use it to draw. And these are some of the images that we created. So this is a castle in Germany. And this is etched onto a grain that's about 1 millimeter in size, and it printed very, very large, about 10 by 10 feet image. And we typically tend to think of computational image, or computational drawings as being scale independent, but our relationship to images is very ergonomic. And a lot of what this work tries to do is to kind of conflate those two scales. So you can really see, you know, the grain and the castle very, very large, and you can see them simultaneously in both sort of states. This is another castle, and this one is the one in France. It took me about 4 years to make this image, which I think took a long time. It was very hard. And throughout this project, I kept asking myself, you know, why don't I just do this in Photoshop? It's like, why am I trying to use this crazy equipment to make this? But you quickly realize that the image carries in its, you know, sort of visual quality, the process of its making, and you can't really sort of fake or kind of mimic that. You can see, for example, on the right side of this image, that there's a sort of piece of the grain that kind of cracked or broke when it was being ablated and was being kind of written on. And I really sort of appreciate the sort of kind of textural qualities you end up getting from the process of making the image. This is another castle in Germany, the Alts Castle. And one thing that I really kind of enjoy with this image too is that there's sort of a fractal symmetry between the kind of outline of the grain with the mountain that's on sort of where the castle is sitting on top of. I can't show you with my cursor, but if you look on the right side of the castle, you can see the sort of little outline of a mountain where the castle sits on, which is very similar to, and that's a line that I drew, but it's very similar to the line and the outline of the grain. Really kind of, again, conflating these experiences of two separate scales being put together. So going from a grain of sand to a pixel, 640 by 480 is an installation that I did that was commissioned by Design Miami, which is this organization that does this design fairs in Miami and in Basel every year, that allows you to experience computation as a kind of physical material that you can physically manipulate, like a pixel-like material. And alluding, you know, through the name to the sort of resolution of old computer displays. So let me play a video of it, and I'll talk on top if the audio's not too loud. So what this allows you to do is, every one of these is a little computer. You can pull them out kind of from the screen and sort of spread them out into the world and move them around. When you touch them, they change color, so you can cycle through a color palette by touching it. And if you touch two at a time, you can transfer colors from one to the other. And this is literally using your body as a wire. So it's literally transferring data through your skin, through your body from one tile to another. It's not wireless in any way. You can do multiple at a time as well. And you can also interact with them as sort of a network, or as a group, by using a remote control to paint them with light. It's like you can paint light with light, if that makes sense. So almost every aspect of this light was custom made. So the enclosures were injection molded and kind of custom designed. Same for the electronics. Even the battery is actually custom made. But what I want to bring a little bit of attention to is the glass. So the glass is kind of a sort of a composite. There's a layer of ITO coated glass which makes it conductive, and a diffuser that gives a sort of nice kind of visual quality to the LED light. And it's connected to a circuit that's custom designed to be able to do capacitive touch sensing, data transmission, and data reception all in one electrode. So it's sort of creating this sort of new materials that, you know, support multiple functionalities in the same substrate. And yeah, so I've been super lucky to show this all over the place, and typically the installations are sort of very large and kind of very, like, if you're really immersed in them, which I think is really special. And I got to see people interact with these in all kinds of different ways. So this is an installation with the Creators Project in San Francisco. This is one with Ars Electronica in Linz. And what I realized is that this project is very much like kind of a digital graffiti. When people first approach it, they start moving these boxes around, which doesn't make a ton of sense, or why would somebody want to do this? But people do that, and they quickly realize they can kind of draw and sketch with it. And very much like sketching or drawing, as people start doodling, and then they'll do 8-bit characters like little Mario and like a Nintendo type of things, and then those evolve into more complex compositions, which I think is quite beautiful and interesting. This was a very interesting exhibit as well. This is at the Corcoran Gallery in Washington, where this is a very traditional museum, so it's the kind of place you go and you're not supposed to touch anything. You get yelled at. But this one you're supposed to touch, but there were no signs telling you this. So the guard who was on the corner would come in and tell people and be like, hey, you can touch it, you can move this stuff around. and then people would start doing this and creating things. And there was one time when I came over there, and there was a group of 10 teachers that discovered the color cloning by themselves. And then they also discovered they could hold hands together and could clone colors across all of them. So when I got there, there's 10 people holding hands and kind of creating things with this wall, which is a very different kind of experience that you have typically with technology, right? It's like very non-physical. It's like it's all kind of devices made for a single person, which I really appreciate. And I think it brings a lot of what I'm interested in creating these kinds of technologies and embedding computation into materials in particular. And what makes this different from a sort of a regular material, more traditional material, is that the behaviors are emergent, right? So from the interaction of all these individual components, you get these different kinds of behaviors that you couldn't quite predict from the kind of individual behaviors that they have. So this is at a collector's place at the Franco Foundation for the Arts. It's probably one of the largest installations, and you can really sort of paint with light with the remote, which is really nice. And yeah, you can see it there. And then also discover that you can actually cover the light coming from the remote control with your body, so you can create this sort of digital silhouettes. Yeah. And the final behavior really emerges from this relationship between people and the sort of network of objects sort of working together. Yeah. So Silver Light is another project. This is a project to explore the use of silver for both its aesthetic but also its electrical properties. It was a collaboration with Aranda Lash for the Museum of the City of New York. And we're tasked with choosing an object from their silver collection and design something that was inspired by that object, but sort of kind of reconsidering the use of silver today. So in the 18th century, silver is used, as a kind of household material or a material used for household objects, such as like cups and plates and cutlery. But today, it's mostly used for making electronics and semiconductors. It's kind of a very different use of materials, and we decided to combine and bring both together. So the way this works is, so this little lamp, this object sort of kind of hints at the sort of candle holders, but it's made from a silver ink that's printed onto this plastic film, and then sort of rolled up to create the object. And the circuit trays provide both the function but also the aesthetics of the object. You can't quite see in this video, but the shadows are quite nice as well. So you have this material that really kind of create multiple functionalities. And this material logic of going from 2D, for a 2D circuit or 2D object to a 3D one, I think is really interesting, especially when you think about manufacturing kind of design opportunities. You could imagine, creating an object, printed in 2D, shipping it that way, and then somebody folds it, puts it back together whenever they receive it. It's a whole other way of thinking about how we do with products. Yeah. So the other project that this is something I've been working on more recently. It's a kind of a design technique that combines parametric design with large language models, and specifically try to take advantage of the sort of expressiveness and imprecision of language to control hundreds of parameters, which otherwise would be very difficult if you had to create a kind of a user interface. So the way this works is that I instruct a large language model with a description of a parametric model that can very plain English, and I specify very clearly the data that we wanted to generate. So in this case, I won't read the whole thing, which says, we're a helpful assistant that generates pen designs based on user feedback. You have to tell it what it is and what it does to get good responses. And then you say a pen design is defined by a series of 16 closed nerves, et cetera, et cetera. And by vertically arranging them, you create circles and you put them together and you create a pen. And then at the end, you have to say, hey, when we ask you to generate a new shape, you should respond with only the rings and points that I want, nothing else. Similar to the example that I've given you, no explanations of your response. If you don't do that, you actually get other stuff in the middle, and it's like, thank you for asking me for stuff. Here are the points you asked for, and then you have to do all kinds of filtering to be able to deal with this. But what you ended up is something like this. So behind this interface, I have a kind of a giant kind of grasshopper project that designs this. But you can then talk to it like you would with just natural language. So he says, hey, make me a pen, make it a little bigger, make it a little smaller, and you can modify the shape in the sort of very expressive but imprecise ways, and you can control many parameters. I think in this one, there's about 192 parameters or so. Yeah. A lot of the work that I'm doing on this project now, if anybody's interested in collaborating or knowing more about it, is integrating physical constraints into it, both from 3D printing but also from the geometry, right? In a pen, there's a cartridge inside, and you don't interfere with it. So there's a lot of limitations to what you can create that I'm working on now. Cool. All right, let me keep going. So the other area is, as I mentioned, objects. Now talking about interactions. So new forms of physical computing enable new ways, new interface modalities, and new kinds of creative tools. So let me show a few examples. So being material is an example of how computing can augment an existing physical object, kind of a more traditional object, you could say. So being material is a book. It uses machine learning, computer vision to augment the physical experience of reading a book without using any electronics or QR codes or visual tags. And this book in particular is focused on the topic of computing in materiality. It was a book that was put together by Skylar Tibbetts from this event that he was organizing, and it was co-designed with Rune Kang and Lucas DeBiase. So, typically when you read a book, this is the experience that we have, and we wanted to keep this experience of being able to read a book the way you traditionally would. But you also wanted to perhaps use a phone or some kind of computing to enhance it, to augment the book without interfering with the original book design. So what we did is we trained an image classifier with over 150 images per spread of the book. So we opened the book, took a bunch of photos of it, with all different kind of lighting conditions, different backgrounds, different positions. And then we built a website that allows you to see the page where you're in and then bring up all the content that's relevant to that page. So this is an example when you go to beingmaterial.mit.edu. And in this example, it's an article that was written by Tal Denin on the aesthetics of growing bacteria. And you just, by pointing your phone at it, you can pull that up, all the videos that Tal created that go along with the text. This also can be used to edit and remix the book. So this is a bookmark that comes with the book that you can sort of move around and then use it to remix the cover. Yeah. So tools is something that I'm also very interested in, being a designer and having worked on designing fabrication tools for a very long time. So NNN is a collaboration that I did with Philips to make architectural lighting interactive using machine learning. So Philips has a super interesting kind of opportunity and problem where they have lights in buildings in almost every major city in the world. But for the most part, they all show the same thing. They show some version of a rainbow, or they show whatever color of the sport team that won some event that week. And they wanted to allow people to be able to create content for those lights in a way that was a little easier, a little more intuitive. So what we did is we developed a software tool that lets you design interactive lighting by creating networks of neural networks, by connecting lots of little networks together into sort of bigger systems. It's a node-based programming environment very similar to Grasshopper that lets you chain the models. So let me show you a few examples. So in this example, there's a model in the middle that extracts colors from an image. So for example, if it's the 4th of July, you can load up an image of the American flag and it'll pick up colors that you can then use to display into sort of these rows of lights that are represented by the little circles that are on the right. This is another example of using, this is Diego, who works with me, or used to work with me at the lab. And Diego is using PoseNet, which is a model that picks up the sort of points of your body, kind of key points, and a skeleton. And then he's using that to control this little red dot and how it moves. It's very easy to kind of pull those together, connect them, and have a system that's very responsive. And then you can combine everything together, right? This can get sort of infinitely complex. So in this case, there's a model that extracts the color of this like fruits. I'm still not sure why he picked that image, by the way, but it's a very interesting one. And then he does some body tracking. And then he did some custom training as well. So based on what he's wearing, he gets different results. And then together, you can create a sort of very rich and complex interaction behaviors. Cool. Keep going. So large language objects is kind of a sort of a research and very exploratory project that I've been working on recently. And it's something that we're actually doing in class this semester here, which I'm really excited about. And you will probably, some of you will probably get to hear a lot more about it soon. So large language objects, it's basically physical interfaces for large language models that help you sort of situate and embody large language models into the physical world, but providing them with physical affordances, basically giving AI a body, if you could think that way. Fundamentally, at the core of this is a software kernel that gives objects sort of natural language interactions, and with it, a knowledge of human culture. and physical grounding by interfaces to sensors and actuators. And you can, of course, also connect to external data sets and APIs and so on. So let me show you some examples. So this is Nawatron. This is a project that was developed by Aria and Yubo. It's a small little device. It has a projector. The sort of little square hole in the front is a little mini projector. It has a camera on top. It has a hand crank that you can use to sort of advance, and a button at the top for turning it on and off. And it's really interesting because it allows you to use shadow puppets. So in this case, you can make like a little dog with your hand to create generative stories, which is, I think, one of the most wonderful things with large language models. Like the ability to create very rich stories very easily is pretty wonderful. I have 2 kids, and we do this a lot, where we like pull up, GPT and like have it tell stories and modify the stories in real time, and it's really wonderful. It's supervised. I never let them do it unsupervised, but hopefully soon they can do it unsupervised. But what this is doing, it's combining GPT-4 for the story generation. It's using DALL-E for generating image, and then they trained a custom classifier for doing the shadow recognition to be able to detect the different animals. Here's a little video of how it works.
Once upon a time, there was a little dog named Max who lived in a small village with his owner.
Try to bring up
Max loved to run free and explore the world around him, but he was always afraid of the nearby forest. One day, Max's owner got lost in the forest, and it was up to Max to save him.
It keeps it going, but I particularly really love the crank interaction. It reminds us kind of old school slide projectors. It's kind of have this disc turning on and displaying image. And this gets infinitely complex with characters and stuff. Anyway, this is another project that was done by Ethan and Z very recently. It's basically a boom box, but with a camera. So you can see like it has a speaker on the left and a camera on the right. And what they did is really interesting. So typically, you hear a song and you dance to a song. They kind of flip that around, where you dance, and then based on how your body moves, it generates a song or it plays an existing song. And it combines PoseNet, which is the same model from the other project that detects, the position of your body and the skeleton, and large language model to recommend songs based on sort of sequence of patterns that you get from the movement. And I'll play a little bit of how it works. When you clap it, that's when it starts paying attention to your emotion. Let me give the subject of the day. Very short little clip. If anybody is interested in this stuff, I have there's maybe about 30 different projects that really embody LLMs into all these different kinds of objects with all new kinds of interactions that I think are super fascinating. I only have a small little kind of sample to show you here. And then the other one that I really love is Mystery for You. So it's a kind of a misinformation detection game, which sounds really interesting, right? Because immediately if you think about large language models, you think about hallucination, you think about misinformation, but in this case they're using it for sort of the opposite. And what it does is it basically tells you a story, like a kind of a news story using GPT. And then it asks what you want to do as the user. And then you have these little cards that are also AI generated, the image that are on the cards. And you can decide where to go next. You can say, hey, maybe let's go talk to the cops about it and see what they know about this story. And then it gives you the next part of the story. They've done a very large study, I think in India, with kids to go through different news stories to see if they could understand, what's something that's real and what's not. How do you find out if it's real? How would you learn more about it? And they got a lot of really interesting results doing these. I kind of really love this sort of old school kind of analog interface for it as well. Great. How are we doing with time? We still have another 10 minutes or so? Yeah, okay. Great, so So I'll show you sort of the kind of the last part now. So by distributing information and agency across people, parts, and tools, you can create this kind of new forms of collaborative design and making. And I'll show you a few projects that do that. So the pop-up factory is an experiment in mass customization where we created a wearable device that was custom designed, 3D printed, assembled, and customized by users in real time and on demand. It was like this sort of very crazy and sort of very rapid project. So we had this event, and people would come into the event. They could sort of silk screen solder paste into circuit boards. There's a little pick and place machine that would assemble boards in real time. And while this was happening, we had this wall of 3D printers making this sort of custom design enclosures. These are not custom generated. It's a sort of, we have a series of kind of parametric designs. You could tweak and modify them a little bit to your liking. So you can get a little bit of an idea here what the sort of different design variations look like. So as a user, you could come in and pick one, or you could tweak a design in particular to what you want and then print it. And then you put it together, you assemble it yourself. And then you put a specific profile into that wearable, like things you like, don't like. And that was used for networking the event. So whenever you brought these together, they would light up green if you had things in common with somebody else, or red if you didn't. It was literally just an excuse to gauge and go and approach somebody and say hi and start a conversation. But so at the core of this, there's a 2.4 gig radio. It's a low power radio, same kind of frequency you have on sort of Wi-Fi or Bluetooth. And it uses signal strength to create this sort of proximity-based mesh network to both detect how far you are, but also to communicate. And then when people come together, it lights up, and they move far away, it shows something else. We've actually experimented with all kinds of things doing this, and I still have a very large amount of this radio. So if anybody has any interesting ideas that requires a lot of radios and LEDs, let me know, and I have what you need. And you can control them together collectively as well. I did this sculpture project. I don't have it here without a desk, where we set up this kind of giant canopy with this light, and then have somebody assemble the structure so they could tell where the parts were because of the proximity, and then create patterns and animations in the sculpture. Yeah. So Window to the Heart is another project in this vein of sort of collective and distributed fabrication. It was a commission from Times Square to create a sculpture of a heart for Valentine's Day. This is also done in collaboration with Aranda Lash, who they did the Silverlight project with, and with Formlabs. Has everybody here been to Times Square before? Mostly everybody. So it's really hard to do something in Times Square because it's packed with stuff already. So when we got this commission, we went there, sat down, and said, "Hey, let's spend some time looking at this place and think about the kinds of things that we could do." And the first thing that became apparent is that everybody there is taking photos. They're taking photos of themselves. They're taking photos of the space. It's really a place to sort of see and be seen and photograph. And in many ways, it's kind of a sort of metaphor for how we experience the world through cameras and through images today. So we wanted to create a sculpture that really celebrates this culture of seeing. We took inspiration from Fresnel lenses. A Fresnel lens is just a technique that you use to flatten the geometry of a lens, and you sort of chop it up into little pieces, and you kind of flatten them out, where you keep the same optical qualities, but in kind of a much smaller space. But instead of using glass, which requires casting and hand polish, and it's very heavy, we combined the parametric capabilities of 3D printing, which can produce clear parts now with the flexibility of human assembly. So the design we created looks like this. It's supposed to be, maybe if nobody has broken the record yet, the world's largest Fresnel lens, by about 2 inches. And what we did is it was really important that it was the largest. We made sure that it was just large enough. And so this is broken into like 13 concentric circles. They each have kind of the same geometry within the circle. And it totals about like over 1,000 pieces. But except for a few pieces, like in the center where the heart is, there's some specific geometry for those that's a little different. And the way we fabricated this is very interesting. So we used this machine called the Form Cell, which is basically an array of 3D printers, where parts are printed and then kind of pulled out from the machine and kind of put together, and you can then grab and use them. Which I believe is sort of the future of injection molding. It's like a machine that you can just crank out parts, but the geometry can be different per part, and you can keep varying and improving over time. We then assembled it. Had this very hellish 2 weeks at this warehouse in Brooklyn to put this together. Yeah, I would not do this the same way again. If anybody's thinking about doing something like this, I have some advice for you. So one of the reasons why we wanted to use a lens is that rather than adding, let's say, lights to Times Square, which nobody would ever be able to see, you wanted to sort of capture what was already there and kind of reconfigure it. And it's really hard in a project like this. Like, we did simulations and renders. It's really hard to have an idea what things are going to look like until you actually build it. But you get these really beautiful effects where the light from Times Square kind of gets trapped into the sort of the center and kind of repurposed. So this is what the sort of front of the design looks like. You can see a little bit at the bottom, sort of the Coca-Cola sign is it's kind of in the lens. It's sort of redirecting the light this way. And being in Times Square, right, it became a selfie portal immediately. And it was really crazy because I went there like, I don't know, 8 a.m. and then 3 a.m. and there was always a line of people trying to take photos. There was a wedding that happened in front of it, which I thought was super weird. Why would you want to get married in Times Square? But who am I to judge? Anyway, going up a little bit in scale. So this is not a ball; is a large scale drawing that's made out of soccer balls. This was done in anticipation for the World Cup that happened in Brazil, and it was a collaboration with Vic Muniz as well. And really what it does is explore how humans and computers can work together in sort of close collaboration to assemble the sort of large-scale forms. So we started by writing some custom software. We wanted to make an image of soccer ball, so how many do we need? What kind of image can we create? What's the right resolution? What should the balls look like? And at this point, we also had no idea how many balls we could even get. So it was really sort of an experimental stage and a way to sort of simulate the image we could create. It ended up that we created a custom soccer ball that's very much like e-ink. E-ink actually has white and black sort of particles. This actually got a ball and printed half of it white and half of it black. So then by flipping, we could get 2 different colored pixel. And then by putting it halfway, you get the sort of anti-aliasing pixel. It turns out it's a very terrible soccer ball to play soccer with. When somebody kicks it at you, you can't tell how fast it's spinning, so it's very disorienting. And we were inspired by this image from Leonardo da Vinci, this illustration of a truncated hexahedron, which I think is probably the first soccer ball drawing. It was the first one we could find. And this is done for this book on mathematics, and it's this sort of moment in time when a mathematical description of forms and their visual representation came together. So we thought it was a very kind of emblematic image to use for this project. So then we went to the field where we wanted to create the image. We projected it at night and marked it with a string so that we know the areas that we had to fill up with soccer balls during the day. We couldn't actually put the balls in at night because of the shadow from the projection that was coming at an angle. And this is the interesting thing. So to be able to actually assemble this, right, we don't have a giant 3D printer that's capable of handling soccer balls. So we actually had this sort of human interpretable assembly instructions that we could give to a bunch of people and have them assemble this together in parallel. I like to think of it as kind of a human G-code. And what's really interesting about sort of splitting the sort of decision between the computer and people is that people are very smart and they can improvise. So when there are problems or errors, they can go and make changes in real time that you typically couldn't do if you had a system that's controlled by a computer globally. And yeah, you can see a little bit how it was built. So then people came in and started filling it up. And the improvisation piece was really important. So this was done at the Estadio Azteca in Mexico. If you're Brazilian, because Arthur is, it's a very important place in Brazilian soccer history. But what happened here is that during the day it was very hot. And at night it was very cold, so the balls would inflate and deflate a lot. So we built it one day and it came back the next day, and a lot of balls had popped out because they couldn't fit anymore into the structure. And that's when we started improvising, kind of adjusting a little bit by hand, and it worked quite well. And then this is another image that we did. This is the one, sorry, this is not the other image. This is the one in Estadio Azteca, just from a different perspective. What I really love about this footage is that when we were making it, and we were looking at it at the ground level, and it was really hard to see the ball, But as soon as you could see it from above, from a helicopter, you could actually see it from the same perspective that Da Vinci had probably when he drew it. And you could then finally see it pop up in 3D, and I thought that was really special. It's kind of a good reminder, right? The image never really happened. They happen in your mind, not in the world. So I made two, the Statostacker one and this one in Rio. This is the Favela Vidigal in Rio. It's a really beautiful place, and it was really awesome actually to work with the community there to assemble this. And we ended up making two images, and these are the two images. So sort of a diptych and a nod to the sort of Renaissance compositions. It's kind of very, very long and deep backgrounds. And this is the last project I wanted to show, and I'm almost out of time. So following this project for the World Cup, I was invited to co-direct the Rio Paralympic ceremonies in 2016. And it was an incredible honor for all kinds of reasons, but it was, I think, first of all, it was really awesome to craft and tell the story of Brazil, right? I think that it's through things like this that you create a story of a country, of a people, of a history, and I think that was really valuable to me. But I think even more important was to be able to tell the story of Paralympians, overcoming, a world that's not designed for them, sort of transcending the limitations of the human body. And I cannot watch the Olympics anymore. It's like, it just seems so boring in comparison to the Paralympics. There's so much kind of human strength and capability there that's really magical, I find. And it was really important to me that technology played a big role in this event, and especially in augmenting humans. So this is Emmy Purdy. She's a snowboarder, Paralympian, and she's wearing a custom 3D printed dress, and she's dancing samba with a KUKA robot. Robots are really terrible at dancing samba, by the way. Do not attempt. And I ended up spending a lot of time on this one segment that was called Beyond Vision. And I think it's a segment where this relationship between people and humans and technology really took place, and worked together to create a large-scale performance. So what I did is I drew inspiration from the importance of sound for visually impaired athletes to create a communication system that was hybrid. That was hybrid between the sort of electronics and people. And if you can tell, the performer on the right is wearing like headphones, and she's listening to these radio signals, which happen to be the exact same radio signals that the electronics are listening to. And they have a DTMF decoder, which is sort of an old school way of detecting signals over radio using sound. A DTMF is for dual tones, it's two frequencies. When you dial on your phone, this is what you hear. There's like two sounds. So the electronics could detect the same sound that the person could hear, and then together they created a performance. Let me show a little bit what it looked like. That's it. That's all I got. Yeah, thank you. Happy to take any questions.
Yeah, thank you, Marcelo. We now have time for questions.
You can probably yell it too. Yeah, for the people on Zoom. Oh yeah, it's true. Okay.
So first of all, thank you for doing this. This is awesome. I'm so excited that I'm in class. But I feel like a lot of your projects really are very playful. And so I have this question about, when you are coming up with like the inspiration for how your projects start, do you just are they just like, how do I say, like, do they come from like just playing around with things, or are you already given ideas and parameters probably for like your commissioned projects. Like how do you come up with like these really fun things? I guess that's my first one.
The, I don't have like an answer that perhaps covers all of them, but it comes from a few different places. I think that creating a sense of wonder is always really important for me. Also, if I'm not particularly excited about something, then I'm probably not going to want to work on it. Like a lot of these projects are like multi-year projects with a lot of people like that are very complicated. So if you're not excited, it's like why bother, you know? So to me, that's a very important requirement. But then I think that the other part too is like I always try to push the limits of stuff, of technology, of what humans can do, and how we see things. So I think all those things come together, right? You're sort of advancing what's possible, and in doing this, you kind of create magic, and then that's where the wonder comes from, and then seeing people get excited, I get excited, and then that's how a lot of these projects happen. Yeah. And I don't know if we have questions on Zoom as well, but
I have a question.
Go for it.
So I'm really fascinated by the work that you've done with artificial intelligence and also kind of the, you can say, smaller scale projects that have allowed for kind of these networked interactions and emergent human interactions in spaces and in groups. And in seeing also how design frameworks have changed very recently with the advent of AI, I believe I was in a IDEO, I was in an IDEO kind of like seminar, online seminar, and one of the things they told me was it's important to be okay with non-closure as a designer nowadays. What attitude do you think designers should have going into the future, knowing that the technology that they build and the structures that they're, blueprinting are not going to have the direct impact that they can envision, but instead will emerge organically through interactions and peoples?
So I think there's a lot packed in your question. So let me try to answer maybe a few of the things, and if I doesn't cover everything, then let me know. So the first thing, the question about closure, I don't think design is ever done. I think you probably hear me say this at some point, but I think you either run out of time or run out of money, but it's never done. Every single project I showed, I could keep iterating it forever. Like literally, every time I present, I'm like, oh, I should do a version of this. It's a little like that. And that's normal. I think that's natural, and I think that interesting ideas are never really done exploring, so you can sort of keep going. But you do have to stop at some point, right? And then that's you either run out of time or run out of money, and that's when you stop. But then the question of AI, I think, is perhaps even more interesting. Design is changing. It's changing dramatically. I think that and it will change in many ways, and I think it's very important that if you're a designer today, that you engage like directly with the stuff. It's like learn how it all works, learn how to make things with it, and through it. I think that AI will both be a partner, but also be a tool, will be an assistant, and like there's different kind of modes and ways of working with it. But I think even more important is like help shape what the future looks like. I think that that's where, as a designer today, you can really engage and play an important role. The way that I like to think about is that, to me, it's not so much more about designing a chair or a cup, but it's really about designing intelligence itself. It's like what is the AI going to look like? What kind of AI do we want? And I'm typically like, a lot of the times it's like we engage in these discussions like, are these intelligent? Are they super intelligent? Are they less intelligent than humans? Like, none of that matters. I think if I think something is intelligent, it's intelligent enough for me. And that's kind of what it comes down to. And then the more interesting question is, what is this new kind of intelligence that we're making? It's not the same kind of intelligence that we have, and perhaps there's no point in creating one that's very human-like. Let's create other kinds and see what they're capable of. And so I think in many ways it's really exciting. That does not happen very often in history. So I'd say leverage this moment as hard as you can, learn as much as you can, and help shape it.
We have a question online from Pamela Karimi. She says, thank you for your illuminating talk. In your collaborations with Vic Munez, how do you navigate the contrast between his more low-tech, community-centered approach and your high-tech, lab-produced work? How does this collaboration come together successfully?
That's a good question. It's interesting because I don't think I've ever think of my work at high tech. I think in the same way that perhaps Vic doesn't think of his work as low tech. Our interests typically, so we, you know, a lot of these projects happen from a conversation, or like, hey, there's this opportunity to do something. I was thinking about this, I'm interested in that, and then we started kind of nerding out on different ideas, and then those ideas emerge. And they typically merge in some kind of seed of an idea that's not the final project, but through the execution, through some of the kind of constraints and limitations that we have, then the ideas evolve into whatever we end up creating. Yeah, I don't think in terms of high tech or low tech. To me, I think, a hammer and a computer are both technology. You know, I like to describe my classes, for example, as we go from a chisel to AI, and they're equally important and valuable, and they allow you to do different things, and then you get to choose which one to use for the different things that you're making. But it's all tech, and I don't really sort of make that distinction. Yeah.
Thank you so much, Marcelo, for sharing such a diversity of projects and scales. My question was maybe following up on the previous here in person on AI. With the Penn project, what was so interesting is you kind of gave it bounds to play within. And what they're seeing in AI is that it's not about the quantity of data, but the quality of data as well. And so I'm curious, it's so important to design the interfaces of these, you know, large language models. But then how do we also think about designing the data and how designing the data interacts with the way that you craft or think about the object as well? Do you see designers engaging more in that as well?
100%. It's a very short answer to your question, but I think that's the interesting part about what's happening now is that, you know, I think perhaps a traditional way of thinking about design, you know, is like you move things around, you draw lines, you create form, but now curating data, I think, is a form of design. Selecting information is a kind of design, and I think that we don't fully understand what that means or what that looks like and how you do it, but it will become a very important part of it. Because for a lot of these models and a lot of the things, selecting the data, the right kind for the right purpose, is what allows all that stuff to happen in the first place. And then the rest actually just sort of comes naturally off of it. I'm working on a project now to do interactive storytelling or generative storytelling. And a big part of it is curating the data. And it's interesting because you can actually use large language models to create the data for another model. And through the sort of combinations of models and sort of manipulation of data, you can create these experiences. Yeah, so that's another way to design.
Yeah, thank you so much, Marcelo. I have a question about scale,
Yeah.
maybe related directly to the project you did for the Paralympics, because you work at multiple scales, and just thinking about sort of systems of systems, like how do you move from an object to 100 objects, and the sort of choreographies that have to happen, especially in terms of the interfaces between the data sets that I imagine have lots of feedback loops happening. I'm just thinking about the clip that you showed us.
So I think there's a few pieces to perhaps answer that question. So there's a kind of a side of it that's about manufacturing, and there's a side of it that's like how technology works together. So I think one of the perhaps most beautiful things about technology is that if you design the inputs and outputs, when you put things together, they all work together. This project was really crazy because I never got to see the show until the show happened. So it was insane. Right? It's like, how could you possibly do this without actually, you know? But we've tested every piece We've tested how the pieces come together. We had simulations of it. We knew roughly what it was going to look like. But until we actually did it, we didn't know if it was going to work. But you got to trust it, right? You know the things work and they communicate, and then you put it together and you hope everything works together. But then going back to the manufacturing part, I think that's the other very important piece. I think that it's so easy to manufacture things today. It's insane how easy it is. You can literally put a PDF and you send it to a factory in China, and as long as you wire them the money, they'll make the stuff for you. And that includes injection molding, circuit boards, the right software. And I think leveraging that network of, and it's not just one factory, it's like many factories working together and kind of collaborating with you in many ways. I think learning how to do that became very powerful for me to be able to do these projects. The Paralympics one is a really great example too, because I had designed one of the light sticks. I had tested it. There was like radio network. There was like radio design, LED controllers, like memory. There's a bunch of stuff happening that I had all kind of made myself and working with a collaborator on this stuff. And then we brought it to China, and the factory engineer looked at it and he's like, this is not going to work. And I was like, what are you talking about? He's like, this is not good enough. And I was like, what do you mean? I've tested it. It's great. I've designed it. What are you talking about? And he's like, well, people are going to be dancing with these, right? And I was like, yeah. And they're going to drop them, right? I was like, yeah. And then he threw it up in the air, and it fell on the ground, and it like the circuit board split in the middle, kind of. And he's like, that's why. I was like, you're right. And then we worked through improving the design, and both so that it was easy to manufacture, but also so it would actually, resist all the challenges it would encounter in the field. So I think learning how to work with factories, I think, is really important in a way that you're collaborating with them. If you look at the 640x480 project, it was really interesting because a lot of the manufacturing was done in the US. But there are services like Proto Labs where you send the design to, and in 3 weeks they'll send you boxes of injection molded parts. I think this ability of reproducing a design that many times so fast, I think, is pretty incredible. It's wonderful. Yeah.
Hi. Thanks a lot for sharing your work. I also sense that it was really great that in every opportunity you were inviting people to come to you, and I sensed an openness. So I don't really know how you handle so many projects. I mean, it's quite incredible. And to that, I just wonder, what do you have a plan for maintaining a sort of long-term creative practice? Or have you come to a conclusion that kind of you realize that certain things you do on a daily basis, they actually help you to maintain creative practice? And when it comes to design, you mentioned about that device that has a crank, and I can totally relate to this. It made me think at the same time, is it because of my generation can relate to this? So when it comes to designing for the future, for the next generation, what is your thinking there? Do you really think about how many people will be related to that, bringing their own memories and experiences, or do you design something with the hope that some will be related or not? I guess there are so many questions, but I'll be curious to hear which one you want to comment or...
So I think physical things are really compelling in general, I find. I think more compelling than digital things, just because they engage you in a much richer sensorial way, right? They engage with your eyes and your fingers and your skin. And I think because of that, they tend to be more compelling. The crank example to me is really interesting. I mean, we can do it quick. Who has used an 80s slide projector with a little carousel before in this room? Not a lot of people. But the interesting thing is that we got it. We know we've used it. But what was really interesting is that project happened in 1 year in my course. And then the year after that, there was maybe 5 projects with cranks, because everybody loved the idea of the crank, and it sounded like a really compelling way of advancing through stuff. So I think this sort of design ideas or form factors for things sort of are valuable regardless of technology, and I think they come back. Yeah, we bring them back. And then going back to your other question, I don't have a good answer. I have 2 kids. Right now I'm just trying to focus on like making time for stuff. And maybe in a few years that's gonna get a little easier. The one thing that I find to be really helpful to stay creative is just reading. I find that whenever I read, get lots of ideas, like infinite amount of ideas for things. And when I don't, I stop having ideas. That's as good of a strategy that I have. And I think making stuff, like I think that's kind of the other thing too. Like I think a lot of thinking happens through making, and I think we can't forget that. I think that the one thing that kind of breaks my heart these days is that, you know, we're doing a design project. I see this in class a lot, and the students immediately jump to CAD, and I was like, no, hold on a second, like, because you're immediately constraining the possibilities of what you're making, right? Like you're now limited to what this tool can do. Get some cardboard, get some trash. Let's put some trash together, see what comes out of it. We can see it in 3D, we can move it around, we can glue, we can move super fast. And then maybe go to CAD and then bounce back and forth. So I think that keeping things like physically rich, I think is another really good way. And given this time to make stuff, to think, I think is really important too.
So both in class and then like some of the works presented today, I know that there's like a more of a use of like AI, and for me, my experience is more like ChatGPT. And so I wanted to ask like, what's kind of like the boundary that you feel like you would say for like new designers who are not trying to necessarily rely on using chat or any kind of AI all the time, but also willing to kind of like delve into it and use it for creating more generative design practices or new ideas.
You mean like a boundary of like what shouldn't you do? Is that what you're asking?
Yeah, like I don't want to, I wouldn't want anybody to kind of have like a reliance on AI, but I think AI has so many like really cool possibilities in terms of use, and even in just the one-dimensional video game. I think it's given me a lot of like ways to kind of think about the game differently than just like, oh, I need it to write the code for X, Y, and Z kind of thing.
So I tend to think in both directions about this. So one is you should use AI for 100% of everything that you do and go as deep as you can in every aspect you can think of. But then tell us what you found out. Share with other people. Let's learn how this stuff works and learn from each other. And in my class, you should 100% do that and tell us what you've learned. I think that would be really useful. But at the same time, you shouldn't just do that. You should go and learn how to like sand a piece of wood by hand and use a chisel, because you're going to learn from those things as well. And I think bringing them together is very, very powerful. So I don't think it's one versus the other. I think it's both. I think that this world, like, it's really interesting now because I mentioned this earlier. I have kids, you know, they're learning how to read and write. And I'm in the back of my mind, I'm like, you know, how much of this should they actually learn, you know? Because at some point they would just talk to some computer and it would just spit out everything they need. They need to learn both. So like, you need to learn how to do it by hand, but then also learn how to work with AI to make it happen the way that's interesting for you. I've had wonderful experiences working with AI. For brainstorming, for writing, for speeding things up, for working with other people, and I think it's a really amazing technology, but it's not just a one way of doing things. Yeah.
All right, if there are no more questions, please join me in thanking Marcelo for a really excellent lecture, and I think this discussion will certainly continue through the course of the semester. We're so excited that you're here with us for the full academic year. And I just want to remind everyone That upcoming, we have Samuel Letter, who is also one of our inaugural Design Tech Innovation Fellows, coming to us from the Institute for Computational Design and Construction at the University of Stuttgart. He will be lecturing on October 22nd on collective robotic construction. And then on October 29th, Benaz Farahi will be joining us with her lecture on critical matters. And she just joined MIT in the transdisciplinary design position at the Media Lab. So please join us for our upcoming lectures. Thanks so much. Have a great evening. We'll see you soon. Thanks, Marcelo.
Cool. Thank you.